Hey guys, these are the friction notes. This video should be super short. All right, so the two types of friction that we're working with are going to be static friction and sliding friction, also called kinetic friction. So static friction forces are when the surfaces of two objects are at rest relative to one another, and a force exists on one of the objects to set it into motion relative to the other object. Basically what that means, let's say you have a box in front of you that is at rest, and you apply a force to it in order to push it across the floor. So there is a friction force between the floor and that box, and you have to apply a certain amount of force and to get it to move. So that's what a static friction force is ultimately the force between them, and you got to overcome that to move the object. So our formula here, and this is written a little differently than how it's written on your formula sheet, is that you have a static friction force that equals your coefficient of friction, or static friction, times your normal force. All right, so it's a pretty simple formula. You would be given, say, 2 out of the 3 things and solve for the third. So if you had your coefficient and your normal force, you would multiply those two to get your static friction force. If I gave you both forces, you could divide your static friction by your normal force to get your coefficient. And those are the kind of things you'll see. You'll also see these incorporated into free body diagrams as well. So keep in mind that your normal force would be the same as your force of gravity with your regular free body diagram problem. So if you were working on a regular free body diagram problem and you had your force of gravity, know that that's going to be equal to your normal force. On an inclined plane, your normal force is going to equal your perpendicular force, so it's not going to be quite the same there. All right. For your sliding friction, or also called kinetic friction, is more of a proper term for this, really, it involves movement. All right, so a box sliding across the floor is what this is. So you have to push on that box to initially get it to move, and then you're continuing to push on that box so it keeps moving. And it's going to take a different amount of force to keep it moving, all right? A lot of times it's harder to get an object to start moving, and then once you have it going, it's a little easier, and that's what we're looking at here. So the formula is actually set up pretty similar. It's your kinetic friction force equals your coefficient of kinetic friction times your normal force. So on your formula sheet, it's just written as friction equals your coefficient of friction times your normal force. Because they're essentially the same formula, we're just solving for a different coefficient or a different type of friction. So again, you have that coefficient times your normal force. So I'd give you those two things and you solve for the friction force, or you got both forces and you're solving for your coefficient, same thing. Same deal as the first one. So this formula is pretty easy to work with, and I think your math skills are up to the challenge, so I'm not going to work out an example problem, but let me know in class if you guys need help with this. All right. Thanks for watching.